Consider a small ball of radius r falling through a viscous liquid of viscosity with a velocity v, full stop. Derive the exact form of relation between the viscous force F experienced by the ball and R, viscosity coefficient V, given that F is equals to K R raised to power X mu raised to power Y V raised to power Z, where K is a dimensionless constant and X, Y, Z are to be determined by method of dimensions. Bye. Welcome. This is Academic Daddy, and today we are going to be solving the question right before us. Let's start. Luckily enough, we are given this equation, and any situation where it's not given, you need to know that the first rule of dimensional analysis, or when they tell you using dimensional method, that the first rule is to assume that the dependent, which is in this case F, is equal to the product of the given variables. These are the given variables: radius, viscosity coefficient, velocity. We assume that the dependent is equal to the products raised to the power of unknowns. And the minute we introduce equality, equality, we remove proportionality constant and introduce equality sign. We always introduce a constant, which we say that is a dimensionless constant. So the first rule of dimensional method is to assume when this equation is not given. Any question on a dimensional analysis, if it's not given, you are to remember that you first of all assume the dependent to be a product of these variables raised to unknown power, and it will carry a dimensionless constant. Alright, with that said, let's start. Welcome, Academic Daddy. F is equals to K R raised to power X. So the next thing I'll ask myself is force. Remember, we are asked in this question, the only thing we are looking for is just to find these powers. It's not complicated. Force from our previous class, force is simply mLT raised to power minus 2. Go and watch our video on surface tension and dimensional analysis of derived quantities. So you see how we come about this. So equals to KR, the dimension, and remember dimension is the measurement of physical quantities using mass, length, and time. Dimension of R is simply length, and lo, R means radius, distance in a distance of a circle, distance found in a circle. So S to power X. Viscosity, from our previous class, we said that viscosity is the ratio of force to area, to the ratio of force to the product of area and velocity gradient. And in that class, we got viscosity to be the same thing as mL raised to power minus 1 T raised to power minus 1. That is what we got viscosity to be. So that means everything here raised to power Y. Then V in the question, they said that V is for velocity. See, it's velocity V. So V, we know that velocity is simply LT raised to power minus 1. LT raised to power minus 1. So if that be the case, all raised to power Z. Raised to power Z. So at this junction, all we need to do is to distribute. So notice this is dimensionless constant 1, and if we replace 1 times everything is still everything here. So let's just put everything here down. So I have Lx. Then let's use distributive power law indices for this. So that I have m raised to power y, L minus 1 raised to power y, raised to the power y, then t minus 1 raised to the power y, then L second bracket for velocity raised to the power z, t minus 1 raised to the power z. So at this junction, let me still bring down my force left hand side. For the right hand side, I'll use the method of multiplication. That is multiplication law in indices. I'll apply it so that I now have all the L. Since the bases are the same, multiplication law says if the bases are the same, add the powers. Have L x plus minus 1 times y. Anything times 1 is 13. So it will be plus minus y, which is the same thing as saying minus y. Then come to this side. Then this is plus z. That is for n. Then for m, I have only one m here. M raised to the power y. That is all. Then for t, I have here t raised to the power minus 1 times y is just minus y. Then I have here minus 1 z, which is minus z, so minus z. On the right hand side, I have mlt minus 2. So we now do what we call equating of powers, or equating the bases. So if I equate the bases, I will now have that this is the same thing as saying anything standing on this one is raised to power 1. That is raised to power 1, and this is raised to power minus 2. So let's equate the bases. We say for m, it is going to be on the left hand side. You have 1 equals to y. Because on the right hand side, m is equals to y. M is carrying y. So we are equating the bases. So we have 1 on the left hand side and y on the right hand side. So for L, you see that on the left hand side we have 1 equals to x minus y plus z. So let's leave it at this. For t, notice that for t, on the left hand side we have minus 2. Right hand side we have minus y minus z. So but notice that we've gotten y is equals to 1. So let's do this. This will now be minus 2. Anywhere I see y, I replace it with 1. So minus 1 minus z. And notice that this is the same thing as minus 2 equals to minus 1 minus z. Are you seeing it? Because I have 1. So I replaced it. So minus 1 minus z. Now notice that this can say, let's cross equality sign. If this cross equality sign, I will now have minus z this side equals to minus 2 plus 1 minus z going to minus 2 plus 1 is the same thing as saying minus 1. Now notice this side has minus, this side has minus. I can say divide both sides by minus 1, or you see when minus cross equality sign it becomes plus 1. So z is equals to 1. So since we've gotten z to be equals to 1, we can go back here for L. Remember that we have 1 here. So x is equals to, we have x minus y is 1 plus z is 1. So we simply have x is equals to, x is going to be minus 1 plus 1. Everything here is 0. So x is equals to 1. Therefore, x is equals to 1. x is equals to 1. So if that be the case, we've now gotten that x is equals to y is equals to z. Everything is equals to 1. They are equal. Everything we've gotten here is equal. So let's go back. Remember, we now go back as a science student. We say, remember that F is equals to, remember, F is equals to KRX, coefficient of viscosity raised to power y and velocity raised to power z. So we replace everything with the values now. So that this becomes KRX is 1, y is 1, z is 1. So anything raised to power 1 is that, which means that F is equals to KR. Very simple. This is our final answer. This is our final answer.